Hello, everybody. My name is Aaron Tay from the Singapore Management University. I'm honored to be here to be on the panel on the impact of AI on libraries. Because the impact of AI on libraries is huge and diverse, I'm going to focus on one area which I'm probably more familiar with, which is the possible impact of AI on search and discovery. Since the pandemic, there has been many new innovative discovery tools emerging. For example, there's been a class of tools that I call citation-based literature mapping services that allow you to actually discover relevant and similar papers using citation relationships. This is due to the huge availability of open scholar metadata, and these tools include ResearchRabbit, Lead Maps, Connected Papers, Citation Gecko, and more. At the same time, there has been the rise of tools that use citation sentiment, right? These are basically tools that use machine learning to classify citations into different categories. For example, you could have a tool that classifies citations into whether they are mentioning the paper, or whether their results support, or whether their support contradicts a paper, right? So there are tools like scite.ai, Semantic Scholar, even Web of Science currently has a pilot along the same lines. But for today, I'm going to focus on one specific area that's extremely trendy and hot, which is basically search engines that are using transformer-based large language models. Of course, the most famous transformer-based large language model is OpenAI's ChatGPT, which is actually GPT 3.5. And of course, they have the latest GPT-4 model. Of course, these are not the only transformer-based large language models. Google has the BERT model as well as the PaLM-2 model, and Meta has released the open source Llama model. So the excitement along language models are not new, right? But the latest generation of transformer-based large language models is because it's leading to a lot of excitement, basically because they have achieved state-of-art, near human, I would say, natural language generation capabilities as well as natural language understanding capabilities, right? So by applying these capabilities in all areas of AI, we are getting very interesting applications. In the area of search, I see these capabilities being used in three main ways. Firstly, the capability of such language models to understand the actual query and understand the document. This allows improved relevancy. Secondly, these models are able to generate direct answers to questions, right? So this is a total different paradigm from just generating links to, say, 10 documents that may or may not answer your question. And thirdly, because they are able to extract information from the papers itself, this can be used to enhance search engine results pages, which makes it easier for searchers to actually navigate basically the literature space, right? So it's easier for you to tell whether this paper is relevant to you or not. For example, if it's able to extract immediately whether it's a randomized control trial or not. In terms of the move towards semantic search, this is something that's been going on for a while. So this isn't something that's new. For example, Google has reported that they have been using their BERT language model for about 10% of their queries since 2019, right? So the BERT model is actually enables Google to queries to actually the Google search engine to kind of better understand the query, right? So the traditional lexical or keyword search method tends to ignore the order of the words, right? But when you use semantic search or neural search, they actually take into account like the order of words, right? So the example they give is if you search something saying I need a visa from Singapore to the US, and someone types I need a visa from the US to Singapore, the latest BERT models, which is a language model, are able to distinguish between the two types of queries. right? So of course, I won't go into the whole discussion about how semantic search works, but essentially they are based on embeddings. And back in 2015 or so, the state-of-art embeddings were the word-to-vec and glove embeddings. These days, these large language models produce even better embeddings. Some people call it contextual embeddings or dynamic embeddings. But basically, they have resulted in a boost further towards the push towards semantic search, because semantic search in the past was not very good, was not clearly superior to lexical search. I would argue that the older generation of semantic search is often worse, but the current generation is so good that I see it becoming possibly the default for many search engines. For example, if you compare, say, a keyword search, for example, how to find seminal papers. This is something that I was actually doing a couple of months ago. I was trying to write a blog post about methods to find seminal papers, and I was a bit lazy, so I just threw it in natural language form into Google Scholar, and I threw it into elicit, right? And the results are the different quality, the different the results, the difference in quality of the results are amazing, right? If you look at the Google Scholar, you can see the first 3 or first 5 results. It's just randomly matching things like semantic paper. It's matching the word how, right? It's randomly searching the word find, right? It's not able to use, it probably dropped the word to because it considers a stop word. It's not able to see how to find as a phrase, right? It doesn't seem to realize that how to find is actually a phrase, right? So the semantic query intent is to find how to find semantic papers, right? But if you do it using the latest language models, which can understand your query, as you probably realize it when you type ChatGPT, you can do typos, it still understands, right? So this type of technology is also fueling the matching in semantic search, right? So Elicit is actually using semantic search, and they actually give basically the top 10 or top 5 results are almost all relevant. They are all talking about papers using novel ways to find semantic papers, right? So this is just one example that I noticed by accident when I was doing a search, right? And of course, semantic search does have disadvantages. Firstly, the most obvious is that it's not predictable, right? Because when you do a keyword search, a lexical keyword search, right? It may do things like stemming, lemmatization. It may try to extend, do additional queries. It might match synonyms, but at the base of it, it's still looking at the word by word or the n-gram by n-gram, right? That's the base of it, right? So it's still quite predictable, right? Even people complain Google and Google Scholar particularly is not very predictable, but it kind of is. Most of the time you can see why the results appear, right? Semantic search is different. Semantic search generally just gives you the closest match, right? And it may not even match any or all the keywords inside, right? In fact, you can try this out in Elicit or any semantic search, right? Copy and paste a paragraph of words, right? If you get some results still appearing, there's a high chance you're using a semantic search or you're using some sort of hybrid semantic plus lexical keyword searching, right? If you throw in a whole paragraph of words in Google Scholar, it will usually time out. It will tell us to say there's no results, right? So this is something that you have to warn users about, because we have been used to the idea that most of the keywords, most if not all the keywords in the query will be matched, right? But a lot of these semantic searches if you notice, they don't match every single keyword search, right? In fact, they don't match a lot of it, right? So you can throw in a whole paragraph of stuff and you still get things appearing because they just try to match the closest thing, right? They try to get a sense of what you're looking for and match the closest thing, right? But of course, the one that's probably the most disruptive to search and has the most implications, I think, is the idea that, the fact that people are using these technologies, particularly ChatGPT, to generate direct answers, right? As I mentioned before, all these large language models, they have not just natural language understanding capabilities, but they also have the generation capabilities, right? But there are 2 problems with ChatGPT and language models like ChatGPT, right? If you use them alone, there are 2 issues. Firstly, right, most of you probably know that ChatGPT users training data up to September 2021, right? So if you ask me about anything after 2021, for example, who won the FIFA World Cup, you will never be able to answer, right? And this is not just a quirk of ChatGPT, right? Other language models, like for example, Claude, right? Or Bard, for example, if they are just a pure language model, they tend to have a training date that's cut off that's like months, if not years behind, right? Because it's extremely expensive to train a large language model, right? So I've seen people advise like, okay, so this is the winner of ChatGPT. So why don't we set an assignment question that about things that's after the last training date, right? That is fine. But this alone isn't sufficient because of the later technology that I'm going to talk about, right? I think another serious problem with the current models, large language models, which is even worse, I think, than the fact that the data is maybe old, is that it currently doesn't allow any way to verify answers, right? The current language models, they will just generate an answer, but they are not capable of giving a source, right? If you try to ask them, prompt them to come up with references, they will, but often it is actually made up references, right? This is particularly true for ChatGPT or GPT 3.5. Even the latest GPT-4, which I've tried quite a bit, also makes up references some of the time, right? It's unclear at this stage whether ChatGPT alone or language models alone will be able to solve this hallucination problem. I've read papers where they propose ways to kind of generate, to extract and generate sources, but a lot of this is still in the R&D stage. So the current language models alone, without search alone, they cannot tell you where they got the data from, right? They can't cite the training data that they've been using, at least for the current large language models, right? So the current trendy solution, the solution that is getting very popular, is what in the literature sometimes called retrieval augmented generation, right? So we are not just generating, but we augment it with retrieval. So retrieval in this sense just means a search engine, right? You also see people talk about retrieval augmented large language models, right? They're all the same thing. They're basically saying, let's try to improve the results by using a search engine. So in this example, you can see, instead of just saying, typing in who won the World Cup, right? And instead of just sending it directly to the generator, right? We first send the question to a retriever, a search engine like Bing, right? And Bing will use various methods. There are very advanced, sophisticated methods, but it can be a simple keyword search to look for sentences that may answer the question, right? And these sentences will be then fed to the generator, in this case, ChatGPT, and ChatGPT will be asked to generate an answer based on what the retriever found, right? So this grounds the answer, right? So in this case, it's able to answer. So this is a real query. You type this in say, Bing chat, you are able to actually get an answer. And you, more importantly, not just the right answer, it gives you a link to the web page where it got the answer from, right? So I think this is the most important thing. Even if it's not accurate, you can actually check, right? This is the same thing. It's just showing more in depth, showing that the retriever in this case got 3 sentences from 3 web pages. You can see the prompt given to the ChatGPT. Basically, it says, given a text below, answer the question, and then you will insert the text that was found, right? And it generates answers. So this is actually using Perplexity AI, another AI-powered search engine. So just as there's Google and Google Scholar, there are also web versions, general web versions of this type of technology, as well as academic, right? The most famous and probably the most used search engine that uses this retrieval augmented technology is Bing Chat, right? Perplexity actually launched slightly earlier than Bing Chat, and it's pretty good. You can give it a try as well. U.com is another one. The paper that you'll see later doesn't rate it very highly in terms of accuracy. And Google Bard itself, if you try it, it actually uses a retriever. So if you use Google Bard, you can ask questions that have of events that happened yesterday, and it's still able to find them, which is a telltale sign that it's actually using retrieval augmented techniques, right? So if you ask you use search engines that generate answers and they can give you answers that cite stuff from yesterday, right? Then you know it's probably using retrieval augmented techniques, right? Of course, the academic ones do exist, and the advantage is, of course, sometimes you just want the results to come from academic papers, right? The most famous one is CILIP. Of course, there's things like consensus, even CIte.ai, which I mentioned earlier. Remember the tool that actually uses citation sentiment. They also launched an assistant version of Cite, which actually again searches the Cite database for text that may answer the question, and it generates an answer. And I'll talk about the ChatGPT plugin later. Right, I'll talk about Elicit basically because Elicit, I think they were one of the first academic search engines to actually use such technology. They actually partnered with OpenAI, I think late 2021. Back then they were using, I think, GPT-3, which is an older model than ChatGPT. Currently, they're using a variety of models, including open source models. So the first thing it does is that when you search with a question, like for example, is there an open access citation advantage? On the left-hand side, it actually appears, a generated answer, right? And they are actually coming from the top 4 ranked papers, right? So in this case, because the citations come from the database that it searches, the citations are always real, right? They will never be made up. There are things that it saw in its database, right? But what it can be wrong about is the generated text, right? Just as when a human reads a paper and cites the paper, he might miscite the paper. He might misunderstand what the paper is saying about, but still put a citation, right? So this is similar for such search engines. On the right, you see search engine results page, right? In some ways, it's very similar to a traditional search engine like Google Scholar. It will show you the title, the author, the journal, and the year of publication, right? But what it can do, what it does that's somewhat unique is that it can show other type of characteristics of papers that you can't find because they are not in the metadata, right? So in this case, for example, I've chosen to ask it to display outcome measures. So in this case, for each paper, it's looking at it and asking the system, trying to extract from the full text or the abstract, like for example, what is the outcome measured for open access citation advantage, right? You can ask for the detailed study design, right? In some cases, it doesn't find anything. Maybe because, I don't know, it isn't sure about the answer. And you are not even limited to the predefined columns, right? Fields. In this case, I actually manually typed what was the data set used, and it looked through the paper and went like, oh, no, for this study of open access citation advantage, they are using the random selection of 350 papers and so on. And of course, as I mentioned before, you must not trust what it extracts completely, right? It may misunderstand the paper, right? So if you click on any of these generated text, right, it actually links you to the full text or the paper, maybe the title or abstract, or even sometimes title or abstract if it's from the title or abstract. And you can see the highlighted sentence is where it actually it uses to generate the answer, right? So you can actually verify. You don't have to take it as word that is the answer, right? So this is something that I would say that it should be standard for all systems that generate answers, right? You want to not just have a link to the source, but also to have the exact sentences it uses. Otherwise, you have to spend time reading through the whole paper, right? So right now, Bing Chat gives you the source, but it can be a super long web page or like a 20-page PDF. It's unclear to me, like without which part of the sentence of the page was used to answer the question, right? But things like Elicit, Cite, they actually highlight which parts were used, right? So I find that this is something that I would expect to be standard in all these search engines in the future. Of course, there is something called ChatGPT Plus, which is currently charging at $20 per dollar. If you have that, you will have access to plugins, right? So plugins basically allow ChatGPT to access the internet to do things, right? Among other things. right? So there is a built-in ChatGPT web browsing plugin, which essentially works like Bing. So you will use it to search Bing, and Bing will return the result, and then ChatGPT will try to answer using the results, right? But if you want scholarly kind of matching, currently I think there are 2 or 3 different plugins that searches the scholarly literature. So one is Scholar.io. I kind of asked them what's the data source they're using. I believe they are using, they mentioned that they're using Semantic Scholar dataset as well as OpenAlex, right? So you can see when I asked, is there open access citation advantage? It basically generates, some answers, right? You can even see like what is being sent, what is being searched, and you can see the titles and abstracts that are being sent over that ChatGPT is kind of relying on to answer. Of course, there are many more such academic tools. There is Site Assistant, SciSpace, Zeta Alpha, right? If you're interested in details of these tools, how they're similar, how they differ, I've written several blog posts in the past few months. You can have a look at them. And of course, all these things are evolving. A lot of things that, like for example, Elicit probably might be changing the interface soon. So by the time you watch this video, the interface might look totally different. Of course, one thing to realize is that we are in the very early days of the use of generative AI in search, right? In fact, the idea that the search engine sometimes give a direct answer is not new. I think since 2012 or so, when you search certain questions in Google, like how old is Taylor Swift, or like how tall, you ask certain facts that are well known, Google will sometimes just directly give an answer, right? This answer usually extracted through the Google Knowledge Graph, or occasionally you will actually extract from web pages. This is the, I think the, forgot what's the name of this feature, the snippet, featured snippet feature, right? So it actually, in this case, when I asked, how can you book a room in SMU libraries, it actually pulls out the answer from my webpage, right? So this is already a generative type of AI answer. Of course, at the bottom, you see all the search results, right? The main difference is that now with generative AI being so powerful and popular, we will see a lot more such direct answers appearing, right? So this basically talks about, there's this Google search experience that can be turned on as a beta for people in the US, and you'll see how the generative answers are being displayed. And I think this is an area where there's a lot of room for innovation, right? How do you actually integrate such answers in the best way into the traditional search results, or do you even need traditional search results, right? So what are limitations of these tools, right? So I don't want you to go away with the idea that these tools are perfect and this solves everything. And instead of asking you to use ChatGPT, let's use Bing Chat instead, or let's use Elicit, right? The main thing is that these tools are very new, right? As I mentioned before, Elicit itself is December 2021. Most other tools were launched around the time of ChatGPT, so around the 3rd quarter or 4th quarter of 2022, right? So they're very new. The accuracy and reliability is extremely unclear. I don't know of any study that actually compares Elicit officially. The other thing to note is the source these tools are using, right? Currently, these tools are usually done by startups, and they generally have no access to all the paywall kind of things, right? So what they actually do is that they usually use some sort of open source of data, something like Semantic Scholar or OpenAlex or Crossref, which means that they have the metadata of most scholarly papers, including preprints, right? Because title, abstract, and scholarly metadata is mostly open now, but they'll be limited to the full text that they can actually extract answers from, right? So if you use Elicit, you'll notice that a lot of times the answers, you will tend to produce more answers if you search in a domain there's more open access. So for example, asking a direct answer about something in the life sciences, there's a higher chance that it's able to extract the correct information, as opposed to asking a direct question, say humanities, where the level of OA is not as high. There is enough research to actually suggest that adding a search or adding a retriever to a language model improves accuracy of answers, right? There are several studies that basically just say, okay, this is ChatGPT, right? This is the current number of questions you get correct. if I add in a search engine, what happens, right? So there are a lot of these studies that basically say, yep, the moment you add a search engine, the results go up, right? That's not to say that you add a search engine, you will always get it correct. Sometimes you get it wrong, or sometimes even worse, you will actually make the results worse. So it used to be correct, but the moment you add a search, it gets it wrong, right? So it's not 100% miracle solution, right? But in this case, as you can see, right, the moment you actually put in the evidence, that means you tell ChatGPT what the correct answer is, that means you simulate a retriever that gives it the answer, you can see that the number of correct jumps a lot, right? So normal ChatGPT at the time answers correctly 121 out of about 200 times. It gets it wrong, basically the facts, it got the wrong facts about 31 out of time. But you feed it the right facts, suddenly the accuracy rate is right 185 times out of 200, right? There is just one study I found that compared Bing Chat, Perplexity, and UChat in a very rigorous way, right? Unfortunately, they didn't cover Elysium and all that, but they were actually asked, I guess they were looking for more general search engines, right? So the impressive thing about this study is that they don't just look at that, they actually measure the accuracy or the citation accuracy in two ways, right? Firstly, right, they look at each generated sentence and try to figure out how many % of these sentences has a valid citation, right? That means how many of them have at least one citation that does support the generated sentence, right? And the average for this is only 51.5%. So on average across the 4 search engines, if you look at each sentence, about half of them will have a valid citation, right? Basically, the citation does say what the sentence is saying, right? But of course, if you look deep in the results, you'll see later, UChat is actually very poor. It's clearly the poorest performer of the three. So every time you average it, the results look bad. Right? If you look at the best performing one, right, it's about 74.5%. Right? That means 74.5, about 3/4 of sentences have at least one valid citation. You will see that the next thing that they measure is they just look at the citations itself, and they see how many % of the citations actually fully support the sentence, right? So this is the other way around. They're just looking at the citation level and to see whether each citation is actually supporting the sentence correctly. For this, right, Bing Chat actually did very well. It did about 90%. So 9 out of 10 sentences that have been cited by 9 out of 10 citations by Bing Chat are actually accurate. That means they do support the sentence they are tagged on to, right? So essentially, what you'll find is that having a valid citation for each sentence is a lot harder than just ensuring that your citation is correct, right? The reason for this, which I'll mention later again, is that a lot of these questions in this test set are extremely difficult questions where there's either no web page with the answer, or the answer needs to be supported and cross-referenced across multiple pages, right? So this is why with such type queries, the search engines often fail, and they will just generate a sentence without any citation because they can't find a suitable citation. These are more in-depth. So this is actually showing the citation recall, right? So this is basically asking of all the generated sentences, how many of them have at least one valid citation, right? So you can see that the best ones are like Perplexity, 68.7%, right? So almost 70% of the sentences, generated sentences, do have a valid citation. And the rest of the tables just show how this recall performs across different test conditions, right? So the top, for example, shows specifically test sets they use. All Souls, for example, is one of the hardest entry exams, rumored to be one of the hardest college entry exams. You can see that Bing Chat actually scores about 55.6, and in this case, Perplexity is actually the winner, 63%. So 63% of the generated sentences in Perplexity.ai do support, the citations do support, right? That's what their own internal testing shows, right? It's what this study shows, right? It also shows, if you're interested, how the accuracy of the answer differs depending on where you go to extract the answer. Right? So the easiest one is you extract the answer from a list and it's a short answer, right? So you can see that this is varying about, in the case of perplexity, is about 85.3%, right? The harder questions are things where you actually extract from a table, and also when you are pulling from a paragraph with a long answer. This is the same table, but this time is for citation precision. So this one is more like I look at all the citations and I try to figure out how many of these citations actually support the sentence I'm added to. Right? For this, Bing is very good. It's like 90% accurate. The others are not as accurate, around a 70% range, essentially because the others are not using GPT-4 model. Right? I think even the results so far that I've shown you are actually very, very important. But they went further and they asked users to rate the generated answers in terms of the fluency of the answer, as well as the perceived utility, how useful the answer is. And the stunning thing that they found is that citation accuracy, whether in terms of citation recall and precision, is negative correlated to fluency, is negative correlated to perceived utility. Right? What this actually means is that in general, answers that users find useful or answers that users find to be very fluent tend to have problematic or wrong citations, right? So this has a great IL implication, right? Just because something looks fluent, right? Just because something looks useful and answer the question, and just because something has a citation doesn't mean that they are definitely correct, right? So in this case, if you use elicit to generate such answers and someone actually checked the elicit citations, they will realize that the citations don't actually say what can't actually support the sentences, right? In terms of fluency, right, this also can be explained, right? So if you imagine a search engine that is trying to answer a question, right, and it sees that okay, this sentence A is relevant, right? So it has two choices, right? It can try to paraphrase, right, the answer, in which case the fluency will perceive to be high, but there's a chance that it might misinterpret the citation because it's trying to actually answer not with the exact citation statement, but a variant of it, right? As compared to perceived utility is more a function of whether the answer is useful, right? So because this test set often asks questions where there is the answer either needs to be answered from multiple web pages, from tables, which is tougher, and because and the more you try to paraphrase answers, the more fluent the answer looks. But there's a chance that you might miscite, right? Similarly, right, there are search engines that use extractive technology to just extract the sentence that might answer the question, right? They do not generate like some preamble trying to fit the question to the answer, right? So there are these extractive technologies as opposed to generative technologies where they just extract the sentences they think answer the question, but they have made no attempt to paraphrase, right? So things like scite.ai actually do that, right? So here I already talked about why there's a negative correlation, right? Fluency, basically, the more you try to paraphrase, the more fluent it is, but more likely the general sentence is not supported, right? Or perceived utility, right? Yeah, so if you assume no good answer is found, as I mentioned before, let's say you have a very hard question and you search, none of the results are relevant, it can still try to generate sentences that cite those citations, right? Or more likely, the ChatGPT will come out with an answer that seems to answer the question, but won't have any citations. In terms of implications, there are many implications. I can be here wholly long. But I think one thing to note is that I think chatbots are becoming viable. I know like many libraries, many organizations have chatbots, but they have never been that impressive to me. They take a lot of time to train and they are not very flexible, right? I know of libraries that have already implemented this technology to create a chatbot, but we are still in very early stage. So we're not sure if other products like SpringShare or that might eventually build in such technologies. But in any case, if you want to try how a future chatbot might look like, you can go to Bing Chat, sign on, and then enter I'm a student of XYZ, SMU, for example, and start asking questions. Right? The cool thing is this chatbot actually understands the context. So you don't have to keep reminding you're from SMU or from SMU for SMU. It actually takes that. So in this case, I just show you one screenshot I have where earlier I identified myself from SMU. I asked about access to a certain book. Right? In this case, it says that SMU Library doesn't have this book, which is actually wrong. We do have this book. But the reason why it's not suggesting the book is that because our record in this case is not indexed in Bing, right? However, it's actually indexed in Google, right? So the same page will probably be referenced to if you use Google Bard, which is the equivalent of ChatGPT. Right, the cool thing about this is that even though it says that that it doesn't think we have the book, it doesn't just stop there. It proactively offers and suggests document delivery and ILL. And there's always this sentence that asking about what they can help with. So this is something I've noticed when I use it to help in coding, or that it will actually be very polite, asking me, do I need help and so on. Right. Yeah. So earlier I mentioned that tools like Elicit are based on Semantic Scholar for data, which by law obviously can only allow the use of open access papers. So what is actually happens is that assuming this type of generative AI search tools catch on, and people are actually looking at the generated answers, what we're going to have is that there might be an open access citation advantage, right? If your stuff is online and ChatGPT can use some sort of plugin to find the web page and answer the question, you might actually get more citations, right? You might get more citations, right? You guys are from the UK, so you're familiar with UK, the core, right? So core, as you know, basically one of their jobs is to harvest open access all around the world, including for repositories as well as for open access journals, right? And they have this huge store of not just title and abstract metadata, but also the full text, right? So one of the things that they've been trying, I think since earlier this year, and which they have announced, is something called Core GPT, which is the same idea basically, right? They are using the language models together with the search information that has been found to actually generate an answer. And then, of course, there are further implications. I've talked about user education, right? About how you need to understand and describe to users about these direct answers, how they work, what their weaknesses, right? Of course, there have been studies showing that even GPT-3 can help to create fake news, right? Speed up the creation of fake news. And I actually tried it just for fun. For my local Singapore context, it does it very well. And of course, the long-term effects of using such generative AI to get answers, right? So if everybody just types in a question and gets a direct answer as opposed to being forced to read, right? Will we stop the progress in society? Everything we know is what has been automatically generated, and people start to become instant experts, right? So Google already used to do that, right? So people say that Google destroys the context, right? Because it will just drop you in the middle of a book, a web page, or reference query, reference entry, right? You wouldn't kind of know unless you try to look around, right? But I would also say that that if you switch to like a ChatGPT type model, or even a Elicit or Bing Chat model where the answers are instantly generated, this will lead to people losing even more context, right? So at least if you use Google, you still have to look at the document, right? If you use generative AI like Bing Chat or Bard, right, you won't even see the web page, or you won't even see the book. All you see is what the system interprets as being useful from that book to answer the question. Reference work, obviously, it's easy to predict, right? The number of reference queries has been falling. I think this might be the final nail in the coffin. Because people gravitate to whatever is convenient and a good enough accuracy rate, right? So people have been using Google, people are using Wikipedia, and only if Google and Wikipedia doesn't satisfy them, they will ask a librarian. So similarly, ChatGPT technologies will be similar. I would expect, in fact, I expect not a lot of our users before they consult me to have already consulted ChatGPT, right? And I found this to be true, right? They'll ask me a question and I'll tell you that's the only way to do it. and they will kind of go like, oh yeah, that's what ChatGPT does. Also same with us, right? So this is something that will happen. The other one is more speculative. It's more about the role librarians play in pushing, supporting, or in some cases, if you slowing down the rate of LLMs being created, right? I already mentioned about open access. So if librarians push more for open access, because maybe we think that the value of open access is now greater because machines are using them, then we could probably play a role in trying to push for more open access, right? There also has been studies. I mean, the consensus is slowly shifting towards the fact that large language models, firstly, don't have to be that large, and secondly, they should be trained on quality data as opposed to just taking a copy of the whole internet like the Common Crawl and training on that. Right, so there are studies that actually show that this actually leads to very efficient and powerful models. Like they have a 1 million model that performs at around 100 million model, basically because the 1 million model was trained on the special curated resources, things like textbooks, right? Things like synthetic textbooks, right? So this is something that librarians can think about, because we do have a space in the reading list arena. We do have some space. And of course, the other area that librarians can get involved is in terms of the testing of such tools, as I mentioned before, right? Particularly systematic review librarians or evidence synthesis like specialists. These people generally do have the skill. They do understand search and even search technology to some extent. So they'll be the natural people to actually cut through the hype. Right? As I mentioned before, all these tools may use similar technology, but the quality of execution may vary a lot between them. Right? So not all tools are doing semantic search properly. Some are using semantic search, but maybe they are not tuned. Right? So this is all I have. Thank you very much. I will stop the sharing. Stop the recording.